In oxidation-reduction reactions, electrons flow from reducing agents to oxidizing agents. And those electrons tend to flow even if the reactants and products are in separate beakers. We call the separate beakers half cells. And we can catalog the various half cells with respect to each other in terms of the potential to transfer electrons. In order to do that, we choose one half cell to be the standard. And that standard is the standard hydrogen electrode. At the standard hydrogen electrode, electrons are transferred to hydrogen ions to form hydrogen gas, or hydrogen gas gives up electrons to form hydrogen ions. How do I physically set that up? Well, I take a beaker and I have hydrogen gas at 1 atmosphere pressure bubbling into a hydrogen ion solution at 1 molar. The 1 atmosphere and the 1 molar are to ensure that I'm at the standard state. Now, I'll put a platinum electrode in there, and the platinum electrode acts as an inert conduit for the electrons to flow. Now, I can pair this electrode with any of my other half-cell electrodes. So let's look at that. Let's take this platinum hydrogen electrode and pair it with our copper ion copper metal electrode. When I set that up and measure the potential difference, it comes out to 0.34 volts. That 0.34 volts we attribute entirely to the copper ion copper metal half cell. We say that the hydrogen ion hydrogen gas half cell has a 0 potential. It's the 0 reference point. If we set up that hydrogen standard electrode with a zinc metal zinc electrode, we'll have a potential of minus 0.76 volts. So the opposite potential, electrons flow in the opposite direction in this case. So zinc ion zinc metal electrode has a lower potential than the hydrogen ion hydrogen gas electrode. Now, I can do this for a wide variety of electrodes, but you can see already this allows me to take different pairings. Now I know copper metal copper ion relative to zinc metal zinc ion. So if I formed that half cell and I put zinc ions and zinc metal in conjunction with the copper ion copper metal half cell and measured that voltage, what would that be? Well, we can set up the standard notation. When we do this, we always take the electrode on the right minus the electrode on the left. So in that case, the copper electrode minus the zinc electrode. And we subtract those two voltages, and you get a standard voltage for the copper-zinc system of 1.1 volts. So you can see by using the standard hydrogen electrode as a 0 standard electrode, measuring all our other half cells relative to that, we can then pair any arbitrary half cells and calculate what that standard voltage will be.